So we're going to do 13.1 trig identities. Let's go through the worksheet. Now this first part here is just us. It's just a way for us to help memorize all different trig identities. So first one here, tan. Now a lot of times tan you can say 1 over cotan, but what we actually use the most is tan is sine over cosine. So sine of x over cosine of x. Cosecant, well that's going to be 1 over sine. Cotan, I could say 1 over tan, but what we use the most is sine and cosine. To kind of turn everything to sine and cosine. So we're going to say cotan is just cosine over sine. But the reciprocal of tan. And then secant would be 1 over cosine. So those are the basic ones we learned a couple chapters ago. And then we get to the Pythagorean identities. So these are a little more fancy. So sine squared plus cosine squared equals 1. It's probably the most important one. Comes from the unit circle. So sine squared plus cosine squared equals 1. Super important. And then from there, if I know this, I could get the next two. So if the next one only has sine by itself, so if we only solve for sine, we would subtract cosine from both sides, and you get 1 minus cosine squared. Almost be as important as sine squared plus cosine squared equals 1. And then same thing here. Likewise, if I just have cosine squared by itself, how do I get that? Well, I subtract sine squared from both sides, and I get 1 minus sine squared. So there we go. So again, these shall be review. And then we have the Pythagorean identity, which went over in the notes for this worksheet. The next one are the come from that. So 1 plus tan squared. Now again, to help us memorize, 1 plus tan squared is secant squared. Again, we went over that in the notes. 1 plus cotan squared is cosecant squared. Spelled it wrong. There we go. How do I remember that? I always remember it's the tans plus 1, so tan squared plus 1, cotan plus 1, and the cos go together, so cotan and cosecant, and that leaves tan and secant. So how about secant squared by itself? What does that equal? Well, lots of things. I could say secant squared equals 1 over cosine squared, because the squares kind of combined. I'm going to use this though, so secant squared right here equals 1 plus tan squared. So you could say that also just as good as you said secant squared, you could have said that's 1 over cosine squared. So whatever helps you the most, the problem you're doing. Anyway, that was all just like the warm-up to make sure that we know what we're talking about. Now I just want to simplify the expression. Now the easiest way to do this, for me, is change everything to sine and cosine. So like here, secant and sine. I'm going to leave the sine alone, I'm going to change secant. You go, okay, what's secant? That's 1 over cosine. I'll make sure you put the theta times sine. Now the sine's not a fraction, so you put over 1. Right, so that's just brought that down. I changed that to 1 over cosecant. Now if you multiply these, I get sine over cosine. And sine over cosine is tangent. So tan theta. So that's what this simplifies. Secant theta times sine theta. If you work with it, you get tan theta. 1 minus cosine squared. This is memorization. That is sine squared. Nothing else you can do there. Cosine squared times tan. Sorry, just cosine times tan, no squared. Remember that I want to follow the same rule. Generally, I just want to keep sine and cosine, change everything else. So I'm going to change tan here. And then what does tan equal? Sine over cosine. I'm going to change that by cosine theta. These would cancel out because this is on top and that's on bottom. And you just get sine theta. Let's move on. 1 minus cosine times 1 plus cosine. Well, if you notice, it looks like they want you to multiply it out. So let's do that. 1 times 1 is 1. 1 times cosine is plus cosine theta. Move on to the next one. Negative cosine times 1 is negative cosine. And then I get negative cosine squared theta. If you notice the difference between two squares, you could just also done a squared minus b squared because it's the difference two squares. Anyway, here these cancel out and I get 1 minus cosine squared theta. You might think we're done, but we're not. 1 minus cosine squared theta, sine squared theta. I can't forget. Next one. So I have tan and secant. None of these are sine. So there's lots of ways you can do this. Again, there's actually lots of multiple ways to do this. I might do this 2 ways. But for now, I'm going to do it the way I think most people are comfortable with. Let's change everything to sine and cosine. So tan would be sine squared theta over cosine squared theta. Right? Because again, tan by itself is sine over cosine. Since it's squared, you just make sine and cosine squared. Secant is 1 over cosine. Since it's squared, you make it 1 over cosine squared. So like that. And then I can combine it, since they're both the same denominator, and I get sine squared minus 1 over cosine squared. Something like that. And that might be it. I might be able to go a little bit further. If I was trying to go a little bit further, right? It's hard to tell. I could change sine squared to 1 minus cosine squared. So this becomes 1 minus cosine squared minus 1 over cosine squared. The 1's cancel out. I get negative cosine squared over cosine squared. And those cancel, you just get negative 1. So there you go, negative 1. That was a long one. Right, so this is one way to do it. I just changed tan squared to sine squared over cosine squared. And I changed secant to 1 over cosine squared. They're the same denominator, so you can combine the tops and you get this. Something that felt right, like I felt like I could maybe go a little bit further. So what did I do? I changed sine squared to 1 minus cosine squared, because that's what sine squared equals. And then I simplified and I got negative 1. Again, there's an easier way to do this, and generally, if you look up here, these are the shortcuts. If you know how to use these make your life a lot easier. So to me, these are always the shortcuts. You could do everything you want without them, but if you have them, it makes life so much easier. So like here, secant is 1 plus tan squared. Let's go to this problem right here. Right? Instead of secant, let's change 1 plus tan squared in there. So this would be tan squared theta minus 1 plus tan squared theta. Distribute the 1, you get tan squared theta minus 1 minus tan squared theta. The tans cancel out, and you just get negative 1. So much shorter. So again, there's two ways to do, there's like multiple ways to do each of these problems. If you're just used to changing to sine and cosine, this is probably the best way to do it. If you get really comfortable with this slash row here, they're kind of like the shortcut to all this. So sometimes it makes your life a lot easier. Let's move on. Secant x minus 1, secant x squared, secant x plus 1. We kind of did this one before, we're going to multiply these out. I get secant squared x plus secant x, and then negative secant x minus 1. It's another one where if you notice, it's a difference of two squares, you should get secant squared minus 1. But anyway, that's a long way so we can see it. So I get secant squared x minus 1. Probably done, but let's secant. Does secant equal anything? Secant, well actually secant squared, we just talked about that, right? It's 1 plus tan squared. So this is 1 plus tan squared minus 1. The 1's cancel, you just get tan squared. The next one, 1 minus sine squared over tan squared. So here's a trick I like to do. I don't like dealing with fractions, like most people. So this tan squared here, what I'm going to do is flip it to the top. And how you do that, you make its reciprocal. So tan becomes cotan when you flip it. So that's a trick. Like if I had, just to give a quick example, if I had sine over cosine, I can make the cosine secant on top. Again, I want to do for that one because sine over cosine is tan, but that's the idea. Like if you want to move things to the bottom, to the top, just make it reciprocal. That's going to be helpful here. Instead of tan squared on the bottom, which would be kind of funky, just change the cotan on top. So let me rewrite it, and then we'll simplify it. So sine squared theta, cotan theta. So I get 1 minus sine squared. Remember, I don't like to change my signs. Cotan, though, what is that? Tan is sine over cosine, so cotan is cosine over sine. And then we do a fraction, I always put a 1 over the other thing, so I know it's on top. Right, so that sine turns into sine over 1. Cotan is cosine squared over sine squared. Look what happens. These cancel. So I get 1 minus cosine squared. And we're not done. You know what 1 minus cosine squared equals? Sine squared theta. So like that. So look at the next one. I'm going to do the same thing here. I don't like fractions, right? So I move them both to the top. I'll move this to the top, make it the reciprocal of sine, which is cosecant squared A. I'll move tan to the top and make that its reciprocal, cotan squared A. So cosecant squared A minus cotan squared A. And then let me rewrite it. Now I might have gone around circles here. I think actually I didn't need to do it on this side, because right now when I rewrite, I'm just going to get the same thing back. So that was kind of pointless. But cotan, that's cosine over sine squared. So I get this. Right, so I didn't really need to change this. So that's why a lot of times I don't like to change sine and cosine. I just went back to sine and cosine anyway. So that was my best minute or whatever. And then we get here, and then I could add, they have the same denominator, so you can add them. So you get 1 minus cosine squared over sine squared. This is my variable here, they're all a. Might not think it's important now, but it is important, and become even more important later when we have different variables. And when I get here, and then I'm still not done. 1 minus cosine squared, that is sine squared. So I get sine squared a over sine squared a, which just gets me 1. Next one, that just says the cosine out here, so let's distribute it in. So I have cosine theta secant theta minus cosine squared theta, because you had a cosine times cosine. And now here's a trick. If you ever have a trig function and being multiplied by its reciprocal function, like cosine times secant, you can also get sine times cosecant or tan times cotan. They cancel each other out and you just get 1. Right? I mean, again, if you want to take it slow, I'll show it right here. Right? Secant squared, secant's just 1 over cosine. And then you have cosine. So they cancel each other, you just get 1. Right? So anytime you have a trig function and its reciprocal right next to each other, they just cancel out, you get 1. So 1 minus cosine squared. We know what that is. That's one of our favorites. It's secant. Sine squared. Why did I say secant? So I get that. Next one. Tan cosine squared. Remember, my general rule is, if you're not sure, keep sine and cosine, change the rest. So I'm going to change tan to sine over cosine. I'm going to leave this one the way it is. I like to put over 1 so I know what's going on. And look at stuff cancels. There's 2 cosines up here. There's only 1 down there, so we could cancel out the power of this cosine. I just get sine theta, cosine theta. And that's it, nothing else you can do. Next one. Remember, I don't like this thing on the bottom here, so I'm going to move it up. This trig function on the bottom. And when we move it up, you make it to reciprocal. So cotan theta. So let me just rewrite it so we can see what's going on. So we have cosine theta, cosecant theta, and then cotan theta. So after I do that, after I made it more pleasing to my eye, what you do next is, I like to keep sine and cosine, change everything else. So cosecant becomes 1 over sine. Cotan becomes cosine over sine. Remember, tan is sine over cosine, so cotan would be reciprocal. And then cosine is just cosine over 1 if it helps. In this case, nothing cancels out. I got 2 cosines on top, 2 sines on the bottom. So if I multiply it out, I get cosine squared theta over sine squared theta. Which is pretty good, but there's a better answer than that, right? What's cosine over sine? Cotan. So it's just cotan squared. That's it, simplified as far as possible. So the next one. Now, you should notice something about this one compared to like this one. This one's like this one they want you to distribute. Over here, they actually want to do the opposite. They both have a secant. They want you to factor. It's kind of lending you to tell you, hey, factor this out. So factor out the secant. You're left with tan squared plus 1. Now, lots of ways to do this. Easiest way though is tan squared plus 1 is something we should know. Remember, it's a tan plus 1. Tan squared plus 1 is secant squared right here. 1 plus tan squared, so it's 1 plus a tan, and the co will stay together. So 1 plus tan squared, if I find it, is secant. So this is the same thing as saying secant squared, sorry. So that times secant, I get secant cubed theta, and that's the answer. Next one, cotan times secant. Remember, if it's not sine cosine, I change it. So cotan, we're going to change that to cosine over sine. The more you do it, the easier these get to memorize. Secant becomes 1 over cosine. Cosines cancel out, and I just get 1 over sine. That's pretty good. Go a little bit better though. That's saying cosecant. This next one looks like they want me to distribute, but there might be an easier way. We just talked about it. What's 1 plus tan squared? Secant squared. So what do you think 1 plus cotan squared is? Cosecant squared. And times that by sine. Now these are reciprocals with each other. So honestly, if I want, one of these cancels out. One sine cancels out with one cosecant because they're reciprocal to each other. But I'll show the work. Right, so sine is just sine. Cosecant is 1 over sine squared because it's cosecant squared. And then one of the sines cancel and you get 1 over sine. It's the same thing as saying cosecant. So remember, sine and cosecant reduce each other. So basically if you have sine and cosecant next to each other, they can cancel each other out. But in this case there's a squared on this side, so that's why there's one more cosecant at the end. Tan times cosecant. So tan, again, if I'm not sure, just change it into sine and cosine. Tan is sine over cosine. And cosecant, 1 over cosine. 1 over sine, sorry. The sines cancel out, you get 1 over cosecant, which is the same thing as saying secant. The next one looks scary, but it's actually super easy. Notice they have the same denominator. Just add them up. Combine them. And then 1 over cosine minus cosine squared is just sine squared. So sine squared over sine squared. So I get 1. Right? So easiest way to make this is just you have to start memorizing all these formulas here. Like we go to this next one down here. 1 minus sine squared. That's cosine squared. So I'm left with cosine squared theta over sine squared theta. Now it's just knowing what's cosine over sine squared. Or what's cosine over sine. Cotan. And since they're both squared, I get it squared. Next one, it's the difference of two squares, like I mentioned before. If you're not sure, you can multiply it. It'll work out the same way. We should get this. Again, we can just skip this step and go difference of two squares. Well, you get something like this. The middles cancel. And you get 1 minus sine squared theta. And you go, okay, what's 1 minus sine squared theta? Cosine squared theta. 2 cosecant minus cotan. So lots of ways you can do this. Do I want to do the pro way first? We could try it. So we'll do the pro way first. Pro way is, if you remember, 1 plus cotan squared equals cosecant squared. So right here I have cosecant. So that's the same thing as saying 1 plus, it's supposed to be cotan, sorry. So that's cosecant, so the same thing as saying 1 plus cotan. So something like this. 2, 1 plus cotan squared, because what cosecant equals, minus cotan squared. From right here, like that part's the same. Just that cosecant squared turned into this. And I just brought the cotan. Well, now they have two cotans cancel each other out. It's just 2 times 1, which is 2. So that's the fast way. If you want the longer way, you change everything to sine and cosine. It will work. So do it here in purple. It's 2 times 1 over sine squared, cosecant, minus cotan, which is cosine squared over sine squared. Since they're both the same denominator, you can combine it. So 2, 1 minus cosine squared over sine squared. And then I have 1 minus cosine squared, which is sine squared. Sine squared over sine squared, 1. So it works either way. A little bit longer if you just want to change everything to sine and cosine. If you know the shortcut, if you know where cosecant squared equals 1 plus cotan, then it's a little faster. The next one. Anytime I see two things like this, I think they have anything in common. In this case, they both have a 2. So pull out the 2, factor it out, and then like this. And you go, okay, I have 1 minus sine squared. You should know what that is by now. Cosine squared. And that's it. That's the problem. This next one, I think these are all review. Maybe not. It's been a while. Let's do this anyway. So I'm pretty sure it's a review. Find the exact values of the expression if theta is between 0 and 90. So tell you what angle it is. So draw a triangle in 0 and 90. So here's 0, here's 90. Draw a triangle in there. So there's my theta. It's always the inside one. I know cosine is 2/3. So gatoa, adjacent is 2, hypotenuse is 3. I want to find out what sine is. Well, sine is so. I need opposite over hypotenuse. Now I have hypotenuse. That's easy. That's 3. I don't have the opposite though. So that's a right triangle. Find it. a squared plus b squared equals c squared. So 2 squared plus b squared equals 3 squared. Remember, 3's hypotenuse is always c, and then the rest don't really matter. 4 plus b squared equals 9. B squared equals 5. You subtract the 4. So b equals rad 5. And it's actually a positive rad 5 because it's going up. So this rad 5. So that's my answer, rad 5 over 3. So I like these. For me, these are kind of fun. You just draw the triangle in a certain quadrant, and then you do the rest. So the next one. Between 180 and 270. So here's 0, here's 90, here's 180, here's 270, here's 360. So they wanted quadrant 3 between 180 and 270. So right here, I'm going to draw my triangle. We always go down to the origin, make a right angle with the axis. The angle they're talking about is always the inside one. So I get that. Tan is 2. Remember, TOA, opposite over adjacent. So you know they don't tell me what the adjacent is? I know it's 1, because it has to be a fraction. So TOA, make it opposite of adjacent. So there's no fraction, make it 2 over 1. So my opposite's 2. My adjacent's 1. Now, let's go a little fancier here, right? We went to the left, so it should be negative. We went down, so that should be negative. They want me to find secant. Secant's opposite of cosine, so they essentially want me to find cosine and flip it. Well, cosine is SOHCAHTOA, so adjacent over hypotenuse, which again I don't have. So let's find it. A squared plus b squared equals c squared. This time we're missing hypotenuse, so that's my c. So negative 1, we can say negative 1 squared, doesn't really matter. When you square it, it becomes positive. So I get 1 plus 4 equals c squared. 5 equals c squared. C equals rad 5. Remember, hypotenuse can never be negative, so it's a positive rad 5. So cosine is SOHCAHTOA, so it's negative 1 over rad 5. That makes secant the reciprocal, so negative rad 5. So there we go. A few more of these, because these are so much fun. The next one, I want 270, 360. So that's quadrant 4. Here's 0, here's 90, 180, 270, 360. So I'm a little faster on this one. So I'm on quadrant 4, right here, 270, 360. Let's draw a triangle. Always to the origin, blah blah, make a right angle with the x-axis. It's always the inside angle you want. This time I know cosine is 3/5, so SOHCAHTOA. So my adjacent is negative, it's 3, and my hypotenuse is 5. That's just, I must have copied this one wrong, because that can't be a negative. That's positive going right, that's going down. It must be in the wrong quadrant. Anyway, let's solve it like we would solve it anyway. Ignore the negative for now. That's a typo. That's a positive. Let's find cosecant. So cosecant is the opposite of sine. So we're going to do 1 over so basically. So I need the opposite, which I don't have. Now normally I would find a squared, b squared, c squared, but this is a triangle we should know. If 5 is hypotenuse, you have a 3, this must be a 4. And since we're going down, it's a negative. So a 3, 4, 5 triangle. So would be negative 4 over 5. That's what sine is, but I'm looking for cosecant. So flip it, negative 5 over 4. Just like that. Next one. Similar idea. So cosecant is 3/5. We're using the exact same quadrant, so we're still doing quadrant 4. This one's a little more apt though, it actually works properly. Cosecant is 5/3, so that's a little tricky. Remember, sine is over h. Cosecant is reciprocal of that, so if you flip it, you get what sine should equal, negative 3/5. So this is negative 3 and that's 5. So another 3, 4, 5 triangle, and this is 4. So it's a 3, 4, 5 triangle. And then they want cosine. SOHCAHTOA, so adjacent over hypotenuse, 4/5. Okay, a few more. More simplifying. Okay, so look at this one. We got sine, cosine, and 1 minus cosine squared. So we always kind of start on the more complicated side. 1 minus cosine squared, we should know what that is. That is sine squared. And once you have that, the sine and the sine squared can't reduce. You just get cosine x over sine x. And we should know what that is by now. That is cotan x. These are fun. Next one. Cosine squared, secant squared minus 1. So a couple ways to do this. how do we want to do this? So secant squared minus 1 is probably, I know what secant squared equals. So you could change secant squared to like 1 plus cotan squared if you want to go that way. In this case, I'm just going to distribute. I think that's the easiest way to distribute. I have cosine squared A, secant squared A, minus cosine squared A. Remember what I talked about earlier? If you have a trig function and it's reciprocal, they cancel each other out. So these cancel, you just get 1 minus cosine squared A. And that is sine squared. All those trig functions, trig identities. The next one's a hard one. It's our last one, so we can finish on a hard one here. So I got tan squared theta over secant plus 1. So let's look at tan squared theta. Actually, it's not as hard as, oh, yes it is. Tan squared theta, I could change that to 1 plus secant, oh no, I can't. Secant squared minus 1. Yeah, that's what they want me to do. Okay, sorry for the little delay. So tan squared theta. Now, I could try changing a sine and cosine, but I see a secant down here. If you remember from up earlier, 1 plus tan squared equals secant squared. So I'm going to use that. Now again, if I want to, I could change everything to sine and cosine. It gets a little messy. Still going to be messy, but it's a little easier. Now, if you notice, I don't have tan by itself. It's 1 plus tan. So how do I get tan by itself? In the formula, just solve for tan. Secant squared minus 1. So this is the same thing as saying secant squared minus 1 all over secant plus 1. Should be theta there. Plus 1, right? This is why it's honored algebra 2 trig. Let me make this a little prettier. So I have that. Now, the biggest thing people do, they'll cancel out the secants. No, you can't do that. Right? There's not. You only cancel when they're exactly the same. That's a secant minus 1 to secant plus 1. This is not allowed. That doesn't just get you 1/4. It's bad math, right? If it's a plus or a minus, it's stuck. So these are not, I can't do anything unless they're exactly the same. What I could do though is even more advanced math. Secant squared minus 1. Pretend I give you x squared minus 1. That's factorable. It's the difference of two squares. This is just x minus 1, x plus 1. Same thing happens here. Secant squared minus 1 is just secant minus 1, secant plus 1. And then, hey, look, these are exactly the same. And those you can cancel out because they're exactly the same. They're being multiplied. So that's gone. You're left with secant theta minus 1 plus 1. Right, secant minus 1 from up there. Then the plus 1 we bring down. Well, those cancel out. You just get secant theta. And that was a worksheet.